How's it going, everybody? Alright, so I've made some modifications to the circuit we've been playing around with, and this is it basically. Everybody seems to like to name their circuits, so I'm just calling mine the Borg CHARGER, mainly because it's just a whole slew of everything all Borgified into one charging unit, and yeah, it looks like a bit of a mess, but it's doing quite well, so I thought I'd document it. Not sure if I'm going to post this yet, but we'll see. So just a quick explanation. I've just got a brick, 9-volt brick coming in to a buck converter that converts to a USB into an Arduino. I just wanted to check my buck converter because I haven't used it since I bought it, so I just wanted to see if it works. So that's why the setup. I mean, it's not needed. You just run the Arduino off 12 volts, but or 9 volts. But I just chose to do it this way. And then that's just running a switch through an LED as the current limiter. And that switch is just on the negative of my 25-volt battery array. And then the circuit then is pretty much the same, apart from the fact that I've got a high farad supercapacitor bank here. There's 6 350 farad supercaps there, so as the energy goes through, it flows through that and then charges those up. Then the energy flows through the 6-volt 4.5 amp hour battery, does its resonating and flyback. Flyback goes through a 12-volt rechargeable battery and another 14.4-volt rechargeable, and then back to the source. So what I'm doing and using the Arduino for is to switch this on and off so that this part of the circuit only supplies a pulse of energy, and it's about 100 milliamps in half a second, which then sets up, you can see in the blue line I've got the resonance and all the flybacks and everything inside this circuit for about 30 seconds while charging these batteries up and this battery here from these capacitors. So it's basically just a tank circuit going back and forth and then I'm just picking off the flyback and recharging these batteries. At the same time, the 6-volt is getting charged up because of the constant circling of the energy. And then yeah, every 30 seconds this turns on, replenishes these caps, and it just goes on and on like that. And basically I'm just using the tank here to recharge these batteries in the 6-volt. Just want to see what kind of efficiencies I get with that. The C1 bank, as you can see there, is all these caps here, just in case anybody wants to know. So the total ends up being 21,240 microfarad, nanofarad, and then 21.24 microfarad if you want to convert it down. So this is the whole circuit. Let me just step back so you can get all of it all in one shot. Okay, and then, so yeah, you can see my Arduino there. It's the buck converter. Got a nice switch. It's running the Arduino there. You can see the transistor and LED switch there. That's my 25-volt battery bank. Obviously my transformer I'm using, and it runs down to about 5 milliamps, and then once the Arduino kicks in it pumps about 20 milliamps, and then it resonates and tanks for about 30 seconds and then gets replenished. We can watch this tank about 30 seconds later. I think it's about 26 to 28 seconds in reality. Yep, there we go. Okay, so that's the supercaps that I was talking about, and they're just connected the way I've drawn. and then that's the 6-volt battery there, and then the flyback is charging this battery and this battery here. And the reason I'm doing it this way is because, as you will see, I'll just show you the pulse. It's about half a second. The adrenal is set for half a second on time and 30 seconds or 28 seconds off time. I've tried 555 timers and relays, but the 555 timer is very unreliable when it comes to mark space and all this and that, and it's just too hard to mess around with. This is so simple. You just program it to the exact time frame you want, mark space, everything, and it pulses and does exactly what you want. So I prefer the Adreno for this. That's why I'm using it. There goes another pulse. So you can see, I'll take off the flyback, and it's blinking a lot faster than the camera shows, but everybody knows that cameras don't show everything properly. So you can see it flickering there, and then I'm still getting 100-volt pulses all the way down till basically it doesn't stop until the next pulse. And there goes the next pulse, and it's just a lot brighter. So there's at least 100 volts constantly that these batteries are seeing with no amperage, at least hopefully with no amperage. This battery is seeing the amperage, so this battery is seeing a 20 milliamps, and it's seeing 100 volts as well, because the whole lot, well, it doesn't have to go through it, it goes back to the caps. But I think the reason why this whole thing circulates the way it does is because of the fact that this does see the 100 volts as well. Though some would argue and say that no, they're only seeing about the 25 volts that is on the caps constantly, or whatever they drop down to when that goes to about 5 milliamps. But I reckon it's seeing the 100 volts as well. So let me just zoom out here and let you watch the whole operation. There goes the pulse. So it's tanking right now. Now, it will tank for quite a while, and it seems to be getting, the field seems to be getting higher and higher, because this thing is pulsing really hard. I mean really hard. Before it was quite steady on. Let me just see if I can include the so it's down to about 5 milliamps. There goes another pulse. So what I might do just on camera, I don't have my phone on me, is well, I can use the camera. So after the next pulse, I'm just going to switch the battery so it won't pulse anymore. It will keep pulsing, but the battery won't be activated, so it won't recharge the caps. I just want to see how long it takes for those for that neon to stop. There goes another pulse, and we're off. Just bring this in closer, maybe. There we go. So it's down to just over 5 milliamps, and it's still giving 100 volts. There goes another pulse, but I turned it off, so it's still on. Now I timed this so that when that neon would turn off, the pulse would come in. So obviously this energy is building, because that neon is still going at 100 volts. I bet you it'll still keep going after the second pulse. Yep, it's still going. The second pulse just flashed. So that's a minute of 100 volts that these batteries here are seeing. And it's still going. You can see that's almost, there's nothing there. That's very strange. That milliamp meter is like not seeing anything. And it's still going. Third pulse, still 100 volts, and there we go. I'm just going to turn the battery on. Turn the battery on, but the pulse hasn't come in yet, so we'll just wait for that pulse. Gotta love waiting. But I'm an observer, so I love observing things. I can sit for hours just observing something. And there we go, there's that pulse again. So yeah, just thought I'd show this off. Document its operations. What I might do is reduce the resistance so that that doesn't actually flicker like that. It's more steady on. Then hopefully it will tank for longer. So let me just do that now. Put the camera down. Change my trusty there we go, steady on. So that's at 47k now. And this resonance should last for a lot longer. You can see it's steady on now, it's not flashing. And I'm just waiting for the pulse. There's the pulse. Yeah, nice and steady on. So now we're only bumping up to about 10 milliamps. And you can see it's really not going down fast at all. So we've got nice high voltage, 100 volts at least. I mean, these will turn on from 90 to 110, even higher, but so it's seeing at least 90. You can see the pulses don't charge up to 20 milliamps anymore, only 10 milliamps. That neon just stays on and on and on. I may have to reprogram the Arduino. I might program it later on to be dynamic. It's an idea. So I'll just using its pulse with modulated part. I'll put a sense meter on there, and as that voltage keeps getting sustained for longer and longer, I will adjust that pulse to match however long that neon stays on. It's still bloody on. It was 10 seconds. I'm going to turn it off again. Sorry, this might be a long one, but yeah, I just want to document it on camera. So I've turned the battery on, so the next pulse won't kick in. Just put that in closer. I should lay this out better for filming. You can see the pulse kicked in, but the capacitor didn't get recharged. We are at 5 milliamps. Neon is still going. So my theory is, well, not theory, but like everybody's saying, this tank circuit is coupling to something. And I've got all of my electronics turned off in the room. Well, I've got them plugged in, and obviously I've got the Arduino plugged in. But this happens even without the Arduino, and I might show that just so that just for the people who are either skeptical or just for thoroughness. Let's get thorough. So let's just wait for that neon to turn off. This is taking a while. That's just tanking the whole time. So that, like I said, the blue line, this whole circuit is just constantly tanking it, and pow! The flyback is just recharging this battery back here. And obviously, well, sorry, I keep showing this way, but it's actually tanking this way. Well, it's tanking this way, and you know how most people should know what tank circuit is and how it works by now. If you don't know, then you won't understand what's going on here anyways. Still bloody going. Reading nothing. Nothing at all. Still going. Okay, I think it's just going to take too long if we just sit here and wait for that neon. Funny. It's going to take too long. Alright. Well, I can disconnect the pulsing circuit. And the pulsing circuit will just continue pulsing anyway. I might actually turn that off, just so that in case it doesn't blow anything. Okay, that switch is off. I'll put this in. So now what I've done is just gotten rid of this part. This is no longer doing my switching for me. I've connected this up straight to the battery, and I've got a switch here, which I forgot to show on the diagram. Sorry about that. But that's this switch here. It's on the positive. So it's off. Yay, neon's finally off. Alright, so just to get a better shot, get the battery in there, and I will turn this on. You can see it's on. It's drawing 10 milliamps, just like it was pulsing, so that's good. So that means that this transistor is not limiting anything, and the base is turning on fully. Excellent. You can see that that neon's quite bright. Turn it off, and that's off. And that's a hard off. And you can see it's not the Adreno. The Adreno's not giving it anything. Sorry, again, it's going to be a long one, but I don't have a timer on me, so I'm going to use the camera to time how long this takes for this neon to turn off. And as you can see, it's taking quite a while. So yeah. And again, like I said, none of my instruments are on. Basically, that's the only instruments I have in here. If anybody does want to see around my messy room, then I'm happy to show that, but there's nothing new here anyways. Most people who understand what I'm doing will know this isn't anything too new. What I just wanted to experiment with, and I should probably have explained this in the beginning of the video, is the fact that this is tanking and doing this 100 volts. So that these batteries are seeing that 100 volts over time now. So there's no point in these batteries constantly being on and constantly feeding that 10 milliamps. I mean, I'm just looking for that 100 volts, and that's all I want going into these batteries. And this, the supercaps and the 6 volt is just incidental, so that's just charge recovery. So I'm just trying to get the circuit to recover as much as possible while charging that as well. So I'm technically recovering whatever voltage this gets up to. I mean, 350 farads times 6, that's a lot of farads in here. Nothing as close as a lead acid battery, but still close. And this lead acid battery is getting recharged as well. Very slowly, mind you, but it's still getting recharged. And that's just with the normal circuit. And then the tank circuit is recharging these, and hopefully slightly this as well. Because this does go up in voltage when it's turned on, and it stays at that voltage when it's tanking, and then it slowly drops as it gets to this off state as it is now, and then again gets bumped up with the pulse. So that's my reason for thinking that this is still seeing the 100 volts as well, despite the fact that technically that 100 volts should be getting sucked back into these caps. But I reckon that 100 volts is, I mean, because you're potentializing the line, it doesn't, the way that they teach electronics is water flowing through a pipe is kind of misleading. I don't like that analogy. If you look at electronics that way, then you're obviously trapped in that paradigm of looking at electricity that way. You got to look at it a lot differently, and I just look at the lines being potentialized, and obviously this line here is being potentialized, this cross here, Now the potential can't go through this because there's no connection to ground or anywhere. There's no circuit there. But there is a circuit here and a circuit here, so both 100 volts there and 100 volts there should be easy to understand. These LEDs, I like this idea by Sohei. Good on you, mate. This is a really good idea with the current limiting on the base, because the more current you can limit, the longer this seems to tank as well, and the better it seems to tank. Now I don't have white LEDs here, I have UV LEDs. They seem to block that current quite a bit more, and you can see I've got quite a few here. Now I might experiment with how many there is there and the resistance. So yeah, I'll hopefully get some positive results. I mean, both these batteries are charging, so that's a good result. This battery is charging, that's a good result. And these capacitors are charging, which is a good result. And so what I do also is, when these capacitors charge up to the 2.7 volts or so, I just flip them. So this positive and negative I flip, and then that way the capacitors actually add to the 25 volts and make this a 27 volt potential, which then helps with the circling. And once this drops to about 1 volt or so, I flip it again, and so now it's getting recharged. But this whole circuit is constantly operating, and this is just a small little recovery that I'm playing around with. Hence the reason for the Borg as well. There's just a lot of ideas and a lot of things implemented into this one charger. So yeah, well, if you've watched for this long, thanks for watching. Yeah, hope everybody learned something, and hopefully I will learn something, and hopefully this works pretty well. If it does, I may then experiment with running this Arduino off a 9 volt battery, and possibly using the recovery to charge that 9 volt battery, and hopefully have this run itself. Obviously it won't run forever, but it will run for quite a long time while charging that 6 volt, and then that 9 volt or 12 volt will steadily go down. But you never know, maybe something interesting will happen. You never know. You never know. Alright, I'll hook that up off camera. Back up. So yeah, that's it. That's my fun Borg. That's my Borg charger right now. Thanks for watching. Have fun. Keep experimenting.